Good afternoon, ladies and gentlemen. My name is Stefan Wachowski, and we'll be talking about circuits and gates, logical gates. Aircraft logical systems. The aircraft logical systems follow the same conventions and standards as those used in other electrical applications. Here are stated logical gates that will be discussed with their truth tables. A logical gate is an elementary building block of a digital circuit. Most logic gates have two inputs and one output. At any given moment, every terminal is in one of those two binary conditions, a low 0 or a high 1, and this is represented by different voltage levels. The first one we'll discuss is a buffer. Buffers do not affect the logical state of a digital signal. For example, one input produces a 1 output. Also, a 0 input will produce a 0 output. Buffers are typically used to produce extra current drive at the output. We have the truth table here, as we can see, our input and output with a 0 and 1, 1 readings. And logical gates will only produce a logic 1 output when all inputs are simultaneously at logic 1. Any other input are simultaneously at logic 1. Any other input combination results in a logic 0 output. Or logic gates. Or logic gates will produce a logic 1 output. Whenever any one or more inputs are at logic 1, it will only produce a logic 0 output when all inputs are simultaneously at 0. So any input except for a double 0 will result in a 0, and any others will result in a 1. NOR logic gates. NOR logic gates will only produce a logic 1 output when all inputs are simultaneously at logic 0. Any other combination will produce a logic 0 output. In order to receive a 1 on the output, we need both zeros simultaneously. Any other inputs will result in a 0 output. Exclusive or logic gates. These gates will produce logic 1 outputs whenever either one of the two inputs is at logic 1 and the other is at logic 0. Also, these gates produce a logic 0 output whenever both inputs have the same logical state. Inverted inputs and outputs. In and NO NOR gates that have been discussed are said to have inverted outputs. They are respectively equivalent to and OR gates with their outputs passed through an inverter, which is all represented on this side with the inverter of the NOT gate, the in AND gate, the in OR gate, and the exclusive in OR gate. The aviation uses for logical gates are things such as landing gear readings and also APUs and generators throughout the fuselage. These are just a few examples.